Hi guys, welcome back. Today we are going to learn about vectors. We've got 4 success criteria, and the first one is to understand vectors. So a vector has magnitude, which is size, and a direction. So the number on top of a column vector, if it's positive, you move to the right, and if it's negative, you move to the left. The number on the bottom of a column vector, if it's positive, you move up, and if it's negative, you move down. A scalar quantity is anything in life that can be measured or described by a number. So, for example, temperature or age. So here on the grid, we want to draw the vector 3, 4. So we can pick a point anywhere on the grid, and we go 3 to the right and 4 up. And we join these 2 dots with a line and an arrow to show we've gone from the blue dot to the yellow dot. And that's a vector. This time we want to draw the vector -2, 8. So we can pick a point anywhere on the grid, and we go 2 to the left this time and 8 up. We draw a line between the 2 points, and we draw an arrow to show we've gone from the blue dot to the yellow dot. So this is our vector. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's A, there's B, there's C, there's D, there's E, and there's F. In this example, we want to draw the vector A plus B. So we can add vectors together using the nose to tail method. So we start at the second vector where the first vector ends. So if we draw vector A first, so that's 3 to the right and 4 up. So there's vector A. Then we draw vector B where vector A finished. So that's 2 to the right and 5 down. And there's vector B. So vector A plus B is known as the resultant vector, and that's there. We can also draw the vector B plus A. So we can start anywhere, and we draw vector B. So that's 2 to the right and 5 down. So there's vector B. Then where vector B finished, we draw vector A. So that's 3 to the right and 4 up. And there's vector A. So vector B plus A will be here. Now it doesn't matter which way the vectors are added, the resultant vector will always be the same. And we can see that vector A plus B is the same as vector B plus A. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So here we want to draw the vector F plus G. So we can start anywhere, and we draw vector f, 7 to the right and 1 up. So there's vector f. Then we draw vector g. So that's 3 to the left and 2 up. So there's vector g. So vector f plus g will be this. This time we want to draw the vector 2c. So by multiplying the vector, we change the magnitude, which is the length, but not the direction of the vector. So if we draw c, which is 1 to the right and 2 up, then we draw c again, which is 1 to the right and 2 up again. So there's vector 2c. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So here we want to draw the vector 3q. So if we start anywhere, and we draw q, which is 2 to the left and 1 up. Then we do it again, 2 to the left and 1 up. And then we draw it a third time, 2 to the left and 1 up. So there's the vector 3q. This time we want to draw the vector minus d. So if we start by drawing vector d, so that's 3 to the right and 2 down. So there's vector d. So vector minus d will be minus 3, 2. So that's 3 to the left and 2 up. So that's vector minus d. And you can see that vector d and minus d are the same, they just go in the opposite direction. So a negative sign in front of a vector just reverses the direction, but it keeps the magnitude or the length the same. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So we want to draw the vector minus p. So if we start by drawing p, which is like that, minus p will be 2 minus 5. Which is like that. So there's vector minus p. It's the same as vector p, the arrow just points in the other direction. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's a plus c, there's b minus a, 3c, a plus 2d, 3e minus b, and 2a plus c minus 2b. And now we've completed success criteria 1. So now we're going to move on to number 2, and this is to find basic vectors. So we want to express the vector AE in terms of A and B and C in its simplest form. Now this just means we want to find a path from A to E using the paths that are labelled A, B, C and 2B. So we want to find a way from A to E. So we can go from A to B, which is vector A. Now we can't go straight from B to E because it's not labelled. So I have to go from B to C, then from C to D, and then from D to E. Now because I'm going against the arrow that's on 2B, that's minus 2B because I'm going in the opposite direction to the arrow on 2B. Then I can simplify to A minus B plus C. This time I want to express the vector CD in terms of P and Q in its simplest form. So I want to find a path from C to D. So I have to go from C to F, then from F to E, then from E to D. Now again, because I'm going against the arrow on P, that will be minus P. So I can simplify that to 2P plus 2Q. So the order of the capital letters is important. So for instance, going from C to D is the opposite direction of going from D to C. So this question says this is a regular hexagon and we want to express the vector AD in terms of P and Q in its simplest form. So I want to find a way of travelling from A to D. So I can travel along P from A to O, and then I can go from O to D. So a regular hexagon can be made from congruent triangles. And as you know, the lengths and directions are the same, so are the vectors. So to go from O to D will also be P, because it's exactly the same as the vector A to O. As will these vectors. So to go from A to D, we go from A to O, which is P, and then from O to D, which is P again. So to go from A to D is 2P. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, and there's your amber answers. So now we've completed success criteria 2. So now we're going to move on to number 3, and this is to find vectors using ratios and fractions. So this question says ABC is a triangle, M is the midpoint of AB, so we want to express CM in terms of A and B. So we want to try and get from C to M. So if M is the midpoint of AB, then from A to M is half of AB. And from M to B is also half of AB. So we want to get from C to M. So we go from C to A, and then from A to M. Now, C to A is minus A, because we're going in the opposite direction to the arrow. And A to M is half of A to B. Now, A to B is A plus B. So half of A plus B is a half of A plus a half of B. And this simplifies to minus a half A plus a half B. Here's another example. So ABC is a triangle. E is a point on AB. F is the midpoint of BC. And C is the midpoint of AD. Find the vector FD in terms of A and B. So we want to find a path from F to D. Now, because F is the midpoint, we can say that B to F is half of BC, and F to C is also half of BC. Because C is the midpoint of AD, C to D must also be 2A. So we want to go from F to D. So we can go from F to C, and then from C to D. So that's a half of BC plus 2A. Now BC would be minus 3B plus 2A. So if we expand that bracket, we get minus 3 over 2B plus A plus 2A. And if we simplify that, we get 3A minus 3 over 2B. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So for the green question, we want to find the vector PA in terms of A and B. Now D to P is a half of DC, and P to C is also a half of DC. So to go from P to A, we go from P to C, then from C to B, then from B to A. So PC is a half of DC, CB is minus 4B plus A, and BA is minus 3A minus 2B. Now DC is going from D to A, from A to B, and then from B to C. So that's 4A plus 5B. So we need to half that. It's in the bracket. So that's 2A plus 5 over 2B. Take away 2A minus 6B. Then we can simplify that. So P to A is minus 7 over 2b. For the amber question, we want to find the vector m to n in terms of a and b. So a to m is a half of ab, and m to b is also a half of ab. N to e is a half of ae, and a to n is also a half of ae. So we want to go from m to n. So we can go from m to a, and then from a to n. MA is a half of BA, and AN is a half of AE. So BA is minus A plus B, and AE is A to B plus B to C plus C to D plus D to E, which is all minus B. We then expand the brackets, so by timesing both brackets by a half, which simplifies to minus a half A. Here's another example. This time P is the point on YZ such that YP to PZ is 1 to 3. So we want to find XP in terms of A and B in its simplest form. So when converting ratios to fractions, the denominator, remember, is the total of the ratio. So this means that to go from Y to P is 1/4 of Y to Z. And to go from P to Z is 3/4 of going from Y to Z. So we want to go from X to P. So we go from X to Y, and then from Y to P. X to Y is B, and Y to P is 1/4 of Y to Z. So Y to Z is minus B plus A. So we expand the bracket, and then we simplify. So XP is 1/4 A plus 3/4 B. Here's another example. This time the diagram shows the triangle ABC. P is the point on BC such that BP to PC is 2 to 3. We want to find the vector AP in terms of A and B. So B to P must be 2/5 of B to C, and P to C is 3/5 of going from B to C. So we want to go from A to P. So we go from A to B, and then from B to P. A to B is 2A, and B to P is 2/5 of B to C. Now B to C is minus 2A plus 3B. So we expand that bracket, and then we simplify. So A to P is 6 over 5A plus 6 over 5B. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So for the green question, we want to go from B to P. So C to P is 2/3 of C to A, and P to A is 1/3 of C to A. So to go from B to P, we can go from B to C, then from C to P. So B to C is 2B minus 4A, and C to P is 2/3 of C to A. Now C to A is minus 5B plus 2A. Expand the brackets, and then we simplify. So B to P is minus 8/3 of A minus 4/3 of B. For the amber question, we want to find the vector PC in terms of A and B. So O to P is 1/4 of O to B, and P to B is 3/4 of O to B. Now we want to go from P to C. So we go from P to B, then from B to C. P to B is 3/4 of O to B, and B to C is A minus 2B. So O to B is O to A and A to B. We expand the bracket, and then we simplify. So P to C is 13/4A plus 1/4 B. Here's a challenge question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, ABC is a straight line. B to C to A to B is in the ratio 3 to 2. We want to find the vector O to C in terms of A and B. So C to B is 3/5 of A to C, and A to B is 2/5 of A to C. So we want to go from O to C. So we can go from O to B, then from B to C. O to B is 4A plus 3B, and B to C is 3/5 of A to C. Now A to C, well, if we can't find the full vector, we can try to find one of the fractions of the vector. So we know that A to O and O to B would be A to B. So 2/5 of A to C is minus B minus 2A plus 4A plus 3B. We want 3/5 of A to C. So 3/5 of A to C is 3A plus 3B. And then we can simplify it. So O to C is 7A plus 6B. And now we've completed success criteria 3. So now we're going to move on to number 4, and this is to answer vector proof questions. So to show that two vectors are parallel, you need to show that they are multiples of each other. So for example, AB is parallel to 3A plus 3B because 3A plus 3B is 3 lots of A plus B. So there's A plus B, and there's 3A plus 3B. So we can see that they're parallel to each other. Just one is 3 times as long as the other. To show that two vectors make up a straight line, we need to show that they are parallel and they have a common point. So they would make a straight line because they're parallel to each other and they both share a common point. So in this question, M, X, Y, and N are the midpoints of their lines. We want to prove that XY is parallel to OR. So first of all, we need to find the vectors. So we can fill in any that were not given. And we need to find O to R. Now O to R is 6A, and X to Y will be X to M plus M to Q plus Q to Y. X to M is a half of N to M. M to Q is just A. And Q to Y is a half of Q to R. N to M is N to O plus O to P plus P to M. And Q to R is minus 2A minus 2B plus 6A. So this simplifies to 2A. So O to R is 3 lots of X to Y. So they must be parallel to each other. In this question, ABCD is a quadrilateral. F is the midpoint of AB, and G is the point on AD, so that A to F and F to D is in the ratio 3 to 1. We want to prove that FGE is a straight line. So we find two vectors that form the straight line. So we can find vector f to g first. Is f to a plus a to g. F to a is a half b to a, and a to g is 3/4 a to d. B to a is minus 4a plus 2b, and a to d is a to b plus b to c plus c to d, which is 2a minus b. We then expand the brackets and then simplify. Then we find the vector g to e. So g to e is g to d plus d to e. G to d is 1/4 of a to d, and d to e is b minus 2a. So a to d we already found is 2a minus b. So we expand the bracket and then we simplify. So we can see that g to e is 3 lots of f to g. So they're parallel and they share the common point. The common point here is g. So they must make a straight line. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So for the green question, we want to prove d to a is parallel to p to b. So c to p is 1/4 of c to d, and p to d is 3/4 of c to d. So d to a is 2a plus 3b. So p to b is p to d plus d to a plus a to b. P to d is 3/4 of c to d. D to a is 2a plus 3b. And a to b is minus 5a. C to d is c to b plus b to a plus a to d, which is 12a plus 8d. We then expand the bracket and then simplify. So we can see that p to b is 3 lots of d to a. So one's a multiple of the other, so they must be parallel. For the amber question, we want to prove that MNO is a straight line. So A to M is a half of AB, and M to B is also a half of AB. C to N is a quarter of C to D, and N to D is 3/4 of C to D. So M to N is M to B plus B to C plus C to N. M to B is a half of AB. B to C is A minus B. And Cn is a quarter of CD. A to B is 3A plus 3B. And C to D is 6B minus 2A. So we expand the brackets and then simplify. So M to N is 2A plus 2B. Then we work out N to O. So we go from N to D, then from D to O. N to D is 3/4 of C to D, and D to O is 4A minus 2B. C to D is 6B minus 2A. So we expand the bracket and then simplify. And we can see that M to N is 4/5 of N to O. So one is a multiple of the other, so therefore they must be parallel. And because they share a common point, the common point is N, it must make a straight line. For the red question, we want to prove MND is a straight line. So A to M is a half of AB, and M to B is also a half of AB. B to C, or B to N, is 2/3 of B to C, and N to C is 1/3 of B to C. So M to N is M to B plus B to N. M to B is a half of AB, and B to N is 2/3 of BC. A to B is 4A minus 2B, and B to C is 3B minus 6A. So we expand the brackets and then simplify. Then we find the vector ND. So ND is N to C, then from C to D. NC is 1/3 of BC, and CD is 2 lots of AC. BC is 3B minus 6A, and AC is AB plus BC, which is B minus 2A. So now we expand the brackets and then simplify. We can see that ND is 3 lots of MN. So they're parallel to each other, as one's a multiple of the other. And because they share a common point, the common point is N, they must make a straight line. And finally, the purple question. We want to prove that PQR is a straight line. So A to P is 1/4 of A to B, and P to B is 3/4 of A to B. A to Q is 2/3 of A to C, and Q to C is 1/3 of A to C. So first of all, we find the vector P to Q, which is A to P, P to A, and then A to Q. P to A is 1/4 of B to A, and A to Q is 2/3 of A to C. B to A is minus 2A minus 3B, and A to C is A plus B. So then we expand and then simplify. Then we find the vector Q to R, which is Q to A plus A to R. Q to A is 2/3 of C to A, and A to R is 2A. C to A is minus A minus B. So we expand the bracket and then we simplify. Now we can see that QR is 8 lots of P to Q. So they're parallel to each other and they share the common point of Q. So they must make a straight line. And now we've completed success criteria 4. So now that we've completed the last objective, it's time to end the video. Hope you enjoyed it and hope you found it useful. Make sure to like and subscribe and be sure to check out the videos on the rest of the channel. I'll see you next time. See ya.